In this problem, we need to find the critical numbers of the function, the intervals where the function is increasing and or decreasing, then state the extrema. So we have to find if there are any maximums or minimums. So this means we are using the first derivative test. To use the first derivative test, we have to take the derivative. So let's look at this problem. We have 1/3 x cubed plus 5/2 x squared plus 6x minus 1. Now, usually when you see fractions, you freak out, but don't freak out. It's just a number. Just treat it like any other number that you would have in your problem. So when we look at this, we need to take the derivative. We would use the power rule on each of these sections. So we bring the 3 down and we have 3 times 1/3 x squared plus 2 times 5/2 x plus 6. Now if you look at our denominators and what we multiplied by, this is really 3/1. So these 3's cancel out. And we just have x squared. Over here the 2's cancel out. We have plus 5x plus 6. And once we've taken a derivative, to find our critical numbers are where the derivative is equal to 0, or undefined. Nothing in this derivative could make it undefined, so we are only setting this equal to 0. To find those solutions, we need to factor. So we're going to have 2 binomials. We can split up the x squared to x and x. We need to find 2 numbers that can multiply to 6 and that will add to 5. So our options are 1 and 6, or 2 and 3. If we add 1 and 6, we'll get 7, so those don't work. So we are going to use 2 and 3. Everything in this problem is positive, so everything in our answer will be positive. From here, we can get our critical numbers. So these are our critical numbers right here. X equals -2 and -3. Those are our critical numbers. Now, once we have found our critical numbers, we use those to help us solve the rest of the problem. So we need where our function is increasing and or decreasing. So that means that we need to look at these critical numbers and put them on a line. So we are going to have a number line. -3 is the smallest number, and then -2. In our first derivative test, this is what we're about to do, the first derivative test involves testing numbers on this number line. So we have our critical numbers, and I would suggest writing your test numbers either in a different place or on above the number line if you write your critical numbers below, because you need to distinguish. Because the numbers that you test, you are going to plug into the derivative. So -4 will plug into the derivative. -1, -1 doesn't work. I tried to do that earlier too. Try again. -2.5, yes, it's a decimal. Yes, you will live through this. And -1 goes over here. So these top numbers will be plugged into my derivative. It's the first derivative test, so I need to plug my test numbers into the derivative. My derivative is here and here. I can plug into either one. When I plug in -4, I have -4 plus 2, which is -2, and then I have -4 plus 3, which is -1, so this will give me a positive number. When I plug in -2.5, -2.5 plus 2 is a negative number. -2.5 plus 3 is a positive. A negative times a positive is a negative. Now when I plug in -1, I'll get a positive times a positive, and so I have a positive again. So now that I have used these 3 numbers to figure out the signs, I am done with them. I will never use them again. So I need to look at these signs. This plus means increasing, the minus means decreasing, and the plus means increasing. So these are the signs of our derivatives, which tells us about our original function. So I would suggest you be careful about how you draw your arrows too, because sometimes mistakes can be made if you're drawing your arrows in a different spot or whatever it is you're doing. So when I look at this, I can get my increasing and decreasing intervals. Increasing. My function is increasing from negative infinity to negative 3. We cannot include negative infinity. It is not a number, so it gets a parentheses. We can include negative 3, so it gets a bracket. And then it starts decreasing and then increasing again at negative 2. Negative 2 is a number I can include. And then it goes on to infinity. There's my increasing, and decreasing is just what's left in the middle. Just from negative 3 to negative 2. So I have now answered what are my critical numbers, where is it increasing and decreasing. Now I need to find the extrema. To find the extrema, I am going to use what I have found so far. So I don't need these lines. Extrema happens where the signs in the derivative changes. So my sign changes from positive to negative here, and from negative to positive here. Here I will have a maximum. Here I will have a minimum. Now that I've identified what they are, I need to find the ordered pairs. So the maximum x value here is negative 3. The minimum y value here is negative 2. To find my x values are about my original equation. So to find this y value, I need to plug it back in to the original equation. When I plug in 3 to the original equation, that's that thing with all the fractions up here. You take your calculator and pause the video for a second. If you need calculator practice, if you are not getting the right answers with the calculator, you need to take a minute and do that, okay? But the values that you would get, if you plug in negative 3, you would get negative 5.5. And if you plug in negative 2, you get negative 5.66, and then we round it to 3 decimal places because we are in AP Calculus, negative 5.667. Always 3 decimal places if it's available. So here are our critical numbers, negative 2 and negative 3. Here's our increasing intervals. Here's our decreasing interval. Here's our maximum, and here's our minimum. These are our extrema. And you have solved the problem.